Okay, so we've all been pretty blown away by ChatGPT, right? But what if I told you that the real AI revolution, well, it's not happening on your screen at all. It's happening out there, in the real world, with machines that don't just think, they do. So let's dive in. While we're busy asking an AI on our phones to write a song or a funny email, a totally different kind of intelligence is already out there, getting its hands dirty. We're talking about robots stacking boxes in factories, exploring the deepest parts of the ocean all by themselves. This is physical AI. It's where intelligence finally gets a body. And that's the absolute game changer, right? It's the difference between just talking about the world and actually being able to reach out and touch it. So let's talk about the illusion of pure software. Think of it like a brain in the jar. The AI we're used to, yeah, like ChatGPT, it's this brilliant mind floating in a digital space. It's read basically the entire internet. It can write you an amazing essay, a beautiful poem, but it's completely cut off from reality. It has no hands, no eyes, no way to deal with the messy, unpredictable stuff that makes up our world. And this right here, this really gets to the heart of it. A software AI, it can write you a stunning, perfect poem about surfing. It can describe the feeling of the waves, the balance, the whole nine yards. But a physical AI, it can actually get on the surfboard, fall off 100 times, and learn how to balance. One is all about thinking, the other is all about doing. And here's the thing. This isn't some new problem we just discovered. Go all the way back to the 1950s, and the father of AI himself, Alan Turing, he didn't just dream of software. He imagined a Turing robot that would learn by playing. Fast forward to the 2010s, and we saw it with early self-driving cars. That tiny little delay, that cloud lag, even just a few milliseconds, well, that could be the difference between a safe stop and a serious accident. And it's the same thing today. An AI can write a thesis on physics, but it totally freezes up if it has to deal with a spilled coffee or a single uneven step. It's a genius on paper, but pretty helpless in the real world. Which brings us to the next big step, intelligence you can touch. We're moving it from the cloud to the ground. So how do we fix this brain in a jar problem? Well, it's pretty simple, actually. You give the brain a body. You take that intelligence out of the abstract digital cloud and you plant it firmly on the ground, creating machines that learn by doing, not just by crunching data. And there's a name for this whole idea. It's called embodied intelligence. At its core, it's the principle that true smarts don't just come from analyzing a giant database of text. Nope. Intelligence actually emerges from the physical back and forth between a robot and its environment. It's about learning by doing. I mean, think about it. That's how literally every living thing on Earth learned how to survive. Okay, so let's make this super practical. Picture a robot arm trying to pick up an orange. First, it acts. It gives it a shot, and oops, it drops it. Step 2 is sensing. The tactile sensors in its hand actually feel that failure, the slip, the pressure, everything. And then the most important part, adapt. The AI doesn't just see error 404. It takes that physical feedback and refines its grip, trying a slightly different approach the next time. It's basically building muscle memory one little mistake at a time. And again, this has been a long time coming. This journey started way back in the 1950s with these little robotic tortoises that would just wander around until they found their charging station. It was simple, but it was a start. Then in 2011, you had NASA's Robonaut up on the International Space Station doing complex work. And now you've got robots like the Figure 01, learning to do things like thread a needle after thousands of physical attempts, achieving dexterity that's, well, almost human. Now, besides just being able to do more, there's another massive piece of the puzzle: energy. Running a query through a huge cloud-based AI, like asking GPT-4 a question, that takes a ton of power. It's incredibly energy hungry, but this specialized on-device AI, it is just ridiculously efficient. We're talking a tiny fraction of the energy. And that's what makes truly autonomous, always-on machines actually possible in the real world. Okay, section 3, building the silicon brain, or the rise of neuromorphic chips. So if these new robot bodies need a totally new kind of brain, what does that even look like? Well, the answer is this revolutionary type of hardware called neuromorphic chips. And the idea behind them is, well, it's to build a chip that works just like the neurons in our own brains. So think about it like this. A normal computer chip is like a light that's always on, burning energy whether you're in the room or not. It's just crunching numbers constantly. Neuromorphic chips are completely different. They mimic the brain's spiking neurons, which means they only fire up when they're needed. It's more like a motion detector. They're not constantly thinking, they're constantly aware, just waiting for new information, a touch, a sound, and then they react instantly. And the result of this brain-like design, it's a jaw-dropping leap in efficiency. We are talking 1,000 times greater energy efficiency than the chips we have now. 1,000 times. This is the tech that lets a robot run for days, maybe even weeks, on a single battery, instead of just a couple of hours. It's a total game changer. And this isn't some far-off sci-fi dream. This is happening right now. You've got major players like Intel and IBM already building these things. Intel's Lohi 2 chip, it can help a robot learn how to walk in minutes, not weeks. IBM's North Pole chip absolutely crushes image recognition tasks using a tiny amount of power. There are even huge research projects like Spinnaker that are simulating 1 billion neurons to try and model the brain. We're literally reverse engineering the human brain and putting it on silicon. You know, this all connects back to an idea from the 1940s. A pioneer of cybernetics named Norbert Wiener said, "True intelligence demands feedback loops with the environment." And man, he just nailed it. You can't be truly intelligent if you're not in a constant conversation with the physical world. And these new chips, they're finally making that conversation happen in real time. All right, this brings us to our final section, the dawn of physical AI. This is where the body and the brain finally converge. So here's where it all comes together. We have these amazing advanced robotic bodies, and we have these revolutionary new silicon brains. And for the first time, we're seeing them meet in the middle, creating the first true generation of autonomous physical AI. All those robots you've probably seen in viral videos, Boston Dynamics' Atlas doing backflips, or Tesla's Optimus trying to fold laundry, those are the bodies. They are the physical platforms, the crucibles, where this new kind of intelligence is learning all the stuff that no textbook or dataset could ever teach it. Things like balance, momentum, gravity, basically the common sense physics that we all take for granted. And the impact of this is going to reshape our world. Seriously. We're talking about so-called lights-out factories that can run completely on their own. We're talking about AI-assisted surgery where the tools can adapt in real time to what's happening. Think about autonomous rovers exploring Mars, making their own decisions, or deep sea probes going where we can't. And eventually, we're talking about personal butlers in our homes that don't just follow our commands, but actually learn our routines and anticipate what we need. So this all leads us to one last really big question. As these machines start to learn through actual physical sensation, through touch and pressure and feedback, our whole relationship with them is going to change. So I'll just leave you with this thought. When a robot companion can actually feel the pressure of a hug and then reciprocate with just the right amount of force, is it alive? What does that even mean anymore? Makes you think.